All right, now that should work. Perfect. Thank you for flagging this. Very good. All right, so we are going to talk about Backstage. We are going to talk about where to start your platform engineering initiative. And we can maybe do a little demo of an end-to-end setup. I probably want to correct, some of the perceptions that you have about some of the tools, how to structure them, the pros and cons. I want to make clear that I have nothing against Backstage. I think it's actually a pretty good tool if you do not abuse it. It's great for certain things, and it's not so great for other things. And we are actually going to walk through this bit by bit and see how you can get the most out of all of the different components of your internal developer platform. Cool. So we're going to start off with a few general things on Backstage, what it is, how this is structured. I'm going to talk a little bit about platform architecture, about how to get these things set up and fine-tuned. We can maybe do a demo, and then I'm available for questions. And we can go into technical details, talk about culture. That is absolutely possible. Cool. Fantastic. So here, these are the Backstage boys, as one could see them at KubeCon in Paris this year. You have Spotify Sean, ThoughtWorks Todd, Agile Amy, Exec Eddie, and DevOps Dan, all in one picture. Backstage was first created by, obviously, Spotify internally, but also with some folks at ThoughtWorks. These guys have been are still very active in continuing to maintain and further develop Backstage, as are now other players that come in, offer hosted solutions. I'm a big fan of the work that Red Hat, IBM is doing around this. It's called Red Hat Developer Hub. And we have cases like Harness, I think, that have also a managed version of Backstage, and Rody. So all of those continue to invest and continue to contribute to Backstage, and that is obviously much appreciated. Cool. Now, if we look at platforming with Backstage, I do a lot of platform engineering initiatives, right? So at the moment, we start around one large initiative, and large for me is more than 500 teams every 3 days, roughly. And so I have a lot of insights. I see people coming. I see more and more people coming with that started with Backstage 12 months ago, and are now, looking at the adoption rate, looking at the effort, and are questioning, hey, is this enough to actually keep us as a platform engineering initiative alive? And as an example, I always like to use the case of Netflix. I like to use the case of Netflix because everybody, constantly uses them as the shining example of everything is going great. And everybody wants to be like Netflix. But in this specific case, it didn't go that well for them. And so if in the next days you're at home, you're considering watching Netflix or watching a talk about Netflix, I suggest you watch a talk about Netflix. And it's on YouTube, Platform Con 22. Brian Leatham talks about how they want to build the platform. So they're in the early phases of conceptualizing that. And then in 12 months later, in 2023 Platform Con again, he again looks at what did they get done. Now, Netflix chose a Backstage first approach. They were very much focused on essentially putting a pane of glass onto everything, and then doing the tech docs component, making sure all of this is something that developers can look at. So specifically focused on observability components, on service catalogs, on scaffolding. And if you look at this, he was very euphoric in 22. In 23, he says that famous sentence that really resonated with me: the view and assess experience provides value, but on its own is not yet compelling enough to pull users in away from existing habits and routines. And there's a lot of important stuff in that one sentence. The view and assess experience. That's the first important bit here. Backstage is about viewing stuff, visualizing stuff, maybe trying to assess stuff. It is not really about taking actions. It's about consumption. And that's a little strange because the thing that you often associate with Backstage is scaffolding, functionality, etc. But if you really look at the life cycle of an application, the scaffolding bit is something that you do rarely. You do that at the beginning of the life cycle of a service. But if you look at the entire life, it's, let's say, around for 1,000 days. Then the first day that you are making easier is just a quick blink in history and does not really provide much difference. And so in the end, you have these portals, you have these, or specifically Backstage, as a view and assess layer. And important to say that there's nothing wrong with that. This is great, actually. It's fantastic to sell this to managers. It is great to visualize things for project managers. But now we have to look at the second sentence here. On its own, not yet compelling enough to pull users in away from existing habits and routines. The user here is the developer, meant to be the developer. And that's essentially mostly when we talk about the user and platform engineering, we talk about the developer, which I think in itself is a mistake, because the user should not only be the developer. I'm a fan of having a way more holistic view of what a user is. And the next thing that I think is wrong with that sentence is enough to pull users in away from existing habits and routines. Because in platform engineering, our job is not actually to pull users away from existing habits and routines. It's about meeting the user where the user is. And if we say, in this case, the user is the application developer, where the application developer usually is in code, developing applications. And so I believe it's good practice in platform engineering and interface design to try to limit the break in interfaces as much as possible. Are you able to keep things as code? Keep them as code. If that's not possible, keep them in the CLI. If that's not possible, keep them in the CI, which is also, GitHub Actions is also an interface. And if that's not possible, you can actually then expose stuff in an additional interface like a portal. But don't try to force artificial interface breaks on the user. If we go a little bit into how to solve this paradigm and how to think about how to set that up for success, then the big thing that often happens, and that's also, if we look at the definition of the user here, something that is a result of this, is that we are overly optimizing on the experience of the user persona, the application developer. And that's where I like to use the example of this game that results that in a, if you do the platform architecture setup the wrong way, I call it infrastructure Tetris. And that means you have your Backstage thing here, you have a scaffolding button, and you have a big bucket of all of your resources that have to be maintained. And now you set this up in a way that developers click this scaffolding bucket and they create more and more and more and more resources. For the developer, let's assume this is a good experience, but that goes heavily at the expense of the second group, which is the operations team. And so that's the second thing here. We cannot only look at how do we set the, how do we meet the user where the user is, and the user by default doesn't wake up in the morning in Backstage. And the second thing is, how do we design the structure in a way that the user persona is not only centered on the application developer, because otherwise the existence of such a product like Backstage leads primarily to mistakes and problems. All right, so how do we think about designing platforms more holistically for many users? Well, I think about this by first looking at the different pain points. And the most common ones are the ones from the developers. That's the one that, if you have a debate with somebody, why are you doing platform engineering? It's very often because my developers are exposed to cognitive load. we'll hear things like missing self-service, waiting times, they're slow, all of these things. But if we really think about it, there are a lot of other things that are also painful. And those are things like low standardization, ticket operations, manual reviews, insecure configurations, cost spiraling. And those are things that are more relevant to the infrastructure and operation teams, and maybe even the executive team or the security team. So if we really look at it, platform engineering is a multiplayer game, and it has to be seen as a multiplayer game. And what we do not want is infrastructure Tetris. We do not want to have designs that are overly optimized on one group, and that design optimized on one group goes at the expense of the experience of the other groups. Now, I think in platform engineering, there are two core value drivers. Number one is automation. Like, how can you automate as much of the repetitive things as possible? And the second bit is standardization. And if I'm looking at these things, then I like to structure platform engineering teams, and I see them as, if you want, having spokesperson, ambassadors from the different groups. The developers send developers, and they're then called DevX platform engineers, people that really think about how do I structure the interface towards the developer. They think about these things of how can I make sure that I have the cognitive load and the experience of the platform in mind. And the infrastructure and operation teams, they might want to send infrastructure platform engineers. The executives should have a seat on the table, at least, from a cost perspective. The security team should have a seat on the table from the perspective of how do we design this in a way that we can then greenlight this for production. And all of these personas actually serve, and that is very important, not the manager, they serve the organization. So that means they need to deliver business impact. Time to market and cost down, and innovation, the amount of new stuff that I can deliver has to go up. All right, and now we're slowly getting into the question of how do we design platforms in a way that you have Backstage in the mix, right? That's good. You have the view and assess capability front and center, but at the same time, you're solving that enigma of having to make that a multiplayer game with a high business impact, high return on investment. As I said, I believe the biggest drivers are automation and standardization. And if you think about it, then what you actually need to do is you need to drive those two in order to get a high return on investment. So first, what's for me a low return on investment? It's a good way of helping you understand how I think about these things. A low degree of automation is I have a user, and that user requests a Redis or any resource for an existing workload. And you can see already one interesting thing. Most people, when they talk about Backstage, they think about the scaffolding use case, right? I'm clicking a button, I'm creating a new microservice. And that's sort of, it feels like an obvious thing, but is honestly, scaffolding is a trivial technical problem to solve. Why is it trivial? Because I have no existing dependencies. It's greenfield. Greenfield is always simple, but greenfield doesn't scale. If the core value proposition that you have is on the stuff that you create from scratch into zero existing dependencies, then that might look fancy in a demo that you give to your management, but it's not actually going to deliver long-term return on investment. That's why I always like to use the example of let's create a component, but it has to be folded into something that already exists. That's why this example, give me a Redis for an existing workload. Now, here in this case, and in most cases that I frankly look at, are cases that are that have a low automation profile, it would be configured in a way like you have a GitHub Actions, an ECI, whatever, and Terraform. The user runs this, the Redis is created, maybe you have some interface on top, but then there are a lot of human things that you have to do, tickets you have to write. you have to adopt the application configurations. You might need to get sign-offs. You need to reference secrets. You need to do this for the different environments. Not a high degree of automation. A high degree of automation in my world means you have sophisticated logic that can take that expressed intent, I need a Redis for my workload, and all of the different components are fully automated. The second bit here is standardization. A low degree of standardization to me means you have 500 different repositories where you store your configurations for your different resources. Nobody really knows how they're fitting together. Nobody really knows how, on what level of standardization they are. If you upgrade your databases from version 14 to 15, you do this manually. You have the responsibility for all of those different components in your periphery. So all the developers are responsible for this, or you have some operations teams. That's a really novel idea. And if you have fantastic engineers and you invest an incredible amount into training, that might even work somehow, but it is inefficient. Nobody can tell me that if you have 100 different ways of configuring Postgres and staging, this is a very efficient setup. A highly standardized, efficient setup means all of your databases in staging look the same. Not exactly the same, but you have as little drift and difference in the configuration body between resources of a certain type. Obviously, your Postgres database is configured differently to your MongoDB, but there needs to be a concrete reason and justification why it's okay that the next developer who creates the 101st Postgres database in staging is yet using another combination of 190 parameters in RDS. The only reason, in my mind, that justifies this is not perceived freedom. The only reason that justifies this is that the performance of the application requires this. If the performance of your application requires you to have yet another way of configuring a Postgres in staging, fine, you can create a new golden path if you want. If you just have a standard application that needs average performance, you should use a default, and that default should stay on the global definition for all eternity, for the entirety of the lifecycle of the application. The thing is, to actually have this level of automation and standardization, you need to have a sophisticated backend. You need to have logic handling. And logic handling, if you think about software architecture, and platform architecture is a lot like software architecture, sophisticated logic handling should be done in a backend layer because it's more scalable, because you can maintain it better, because you can work and further develop this. It should be API-based, and it should be significantly more structured than that is possible. And the data model of Backstage is simply not designed to actually deal with this. The data model, the structure of Backstage is designed in a way that it's optimized for the view and assess functionality that Netflix meant in this PlatformCon video, which is why you can absolutely use Backstage, but you should not assume that Backstage itself will give you automation. You should not assume that Backstage itself will give you a lot of standardization. You should assume that Backstage visualizes stuff that you have designed already. Okay, so how do you think about backends, and what do we actually mean if we talk about backends? And I like to dissect the different parts of an internal developer platforms into control planes. You have the developer control plane on top, where you have essentially the different interfaces into your platform. You have the portal, you have the application, you have the version control system with a differentiation between usually application source code repositories and platform source code repositories. You have, and we are going to get to what I mean by that in just a second, in a good design that drives standardization, you want to have the environment agnostic elements of the configuration isolated from the general rules on how a resource is configured in a given context. And then you have the backend, and the backend is the, we call this the integration and delivery plane with your CI pipeline, with your registry, maybe with an orchestrator component, with the CD components. All of that interplays with the monitoring and logging components and with the security plane for policy checking, for secrets management, for identity management. And then you have the resource plane where everything materializes. Okay, so far so good. Now let's actually think about how can we design these different backends. And you have several options. Essentially, the dominant two options at the moment is either pipeline-based or second, graph-based. Pipeline-based versus graph. If we think about our, computer science first semester, probably, it's about, do we write the logic into a linear progression that start, stop, and if branched, or do we compose a resource graph and think about everything in our estate like a graph so that we can actually update the nodes independently of each other? I hope what I just said will become more clear as we carry along. So most pipeline-based setups, you'll be using something like GitHub Actions, Argo CD, maybe Terraform Crossplane, and you're trying essentially to build pipelines or compose pipelines that are able to mimic the behavior of exactly what I said. You have an existing workload, you want to add a Redis, and you want to try to write in pipelines as much as that automation as possible. Now, the good thing about this, and I don't want to be gloomy, but I think honestly the only good thing about this is that you already have pipelines, so you don't have to think about this, and you already sort of know how to use them. The problem is that the pipeline approach itself, pipelines in general, are not a very good thing if it comes to complex logic. Start-stop systems in general are not a very good thing to store complex logic. You need a very large amount of code to cover the possible combinations and the entropy in the system. There are a lot of things that are simply impossible, like logic that goes beyond significant environment progression is difficult, and it's hard to our back, and it is something that I usually say has a hard time scaling beyond 200 engineers. If you want, you need to scale the number of platform engineers almost linearly in order to maintain this. I'm aware many teams are doing this, but if you're looking at how many people are just at the moment going into this graph-based approach and abandoning that, and those are usually the ones that have built the pipeline-based stuff first, that I think is pretty telling. And let me just make clear, the graph-based approach, just to avoid that anybody thinks I'm biased. I mean, I am a little biased because I've been working on graph-based approaches for the last decade, but it's something that is more and more present also in the tools. Microsoft Radius, Syntactics, obviously Humanitec, those are all graph-based approaches. If you are looking at the most modern and the new wave of generational tools here for platform backends, they are all graph-based. Graph-based backends are platform orchestrators. The idea is that you do not actually store all the environment-specific information somewhere, but you generate the app and infrastructure configurations that you execute just in time with the deployment. And to do this, you take a specification by the user, in this case, the developer, who specifies, hey, I need for my service the following dependent resources, but that description is environment agnostic. The platform engineering team generalizes the rules. So they say a Postgres database staging is configured this way. You then bring these two components together, and the orchestration dynamically generates the app and infrastructure configurations and creates this acyclic resource graph. That's going to become more clear in just a second. So the I would say, dominant format to describe these things, the workload specification, to describe the relationship between my service and dependent resources is Score. Score is now a CNCF product, and we are seeing a pretty decent usage and contribution. Score is sitting next to the workload source code. There is one Score file for every microservice or for every service. It doesn't have to be micro. And a Score file is environment agnostic. So it means it contains all of the general description of the world. So in this Score file here, for instance, you can see, hey, I'm a product service. I need a database of type Postgres. I need an S3 bucket. I need a DNS. I need route. And this thing is general, right? It works for dev, staging, local production, all the same thing. Now, obviously, next, in order to create a graph, in order to create a representation in an environment, we need to add the rules. So we need to say, hey, if a developer requests Redis here, for instance, and we are deploying to an environment of type staging, then I want you to use the following way of configuring that in that situation. So the Terraform file, Crossplane file, CloudFormation file, Ansible file, whatever you might want to choose. Okay, now let's put this actually together. The resource graph gets created from the definitions, so which are usually, but don't have to be, supplied by the infrastructure and operation team. You can just as well let the developers do this. So here they say, hey, for staging and Postgres, I want you to use this definition for RDS. So this is in the Amazon world. DNS should be done with Cloudflare. Workloads should have OTel sidecar containers, all of that. And then the abstract description flies in, so the Score file, or you click in a Backstage repository, in a Backstage UI, whatever you want. This flies through this pipeline. The orchestrator analyzes the context, identifies the right resource definitions, and generates an acyclic resource graph. So let's do a little bit of reinforcement learning. Let's say, hey, I'm a developer. I want to add a Redis to an existing workload. That means I'm adding 2 lines of code. It flies through the CI pipeline. The orchestrator identifies the right resource definition, and the graph gets updated. Now, let's say I'm an infrastructure team. I want to update all my Redis across my estate. I now have to do this in only one place, and all the nodes that contain or that consume that definition update as well. So that is a pretty powerful thing here. If you think about this, we can then actually go a step ahead and say everything in my organization is a graph. My entire data model can now be graph-based. I'm the organization. My organization has different applications. Those applications have different environments. They have different services. Different services are running in the environments. The services have resources that depend on them in first and second relationship, if you want. You know, you could have like a Postgres. The Postgres also needs a IAM role, which is another resource. It needs a networking, a service account. All of those are dependencies of resources. And if you have everything in a graph, then very powerful things happen. Now, as an example, first of all, you can just visualize. But if everything's a graph in your backend, you can do that visualization wherever, because every single node is an API endpoint. And you can beautifully aggregate this in something like Backstage. This is where the view and assess capability actually shines. The powerful thing is, if everything's a graph and there's a system who updates the graph, then the graph is always the single source of truth. The graph is always up to date. It's always a representation of what's really out there. And that also means you can ask the graph questions. Now, you could, for instance, say, show me everything that the user Tim can view in blue and everything he can change in green. What does that mean? It means that you can apply role-based access control to your entire estate. You can say your user Tim can see the application too. User Tim can change the development environment, but user Tim can only see staging and production, but not apply changes because user Tim doesn't have the clearance. You can say user Tim is allowed to change all the services, but user Tim is not allowed to change the configuration of a Redis in production. You now have a clear list of all of the dependencies rather than having dozens of different repositories that nobody knows who's responsible for this. Let's take another example. Let's say we have show me all resources of type Redis that are using the same resource definition for Redis in staging in orange. Also very powerful. One request to the API, and the graph will show you, hey, let's look at where we are using Redis on a high degree of standardization across our entire estate. Anyhow, we don't need to go into too much detail here. That's the power of graph-based backends. And once we have a powerful backend, we can put a front end on top. But a front end is a front end is a front end is a front end. It shouldn't contain logic. It should actually aggregate and visualize something. And this is where Backstage is actually perfect. So with this under the hood, we can then actually look at what golden paths are possible. And golden paths are now not only meant for developers as a user group, but also for infrastructure and operations and security, and all of them drive those key driver components, automation and standardization. So if you need an existing S3 bucket for a workload, you need ephemeral environments, you need to upgrade all your Postgres databases, you need to run diffs, you need to run policy checks, you need to scaffold. All of those things are possible in the combination of a view and assess capability and a graphed backend. All right, so let's actually do a little demo here. And I'm going to bring up Backstage. Yeah, here we go. And if you haven't seen Backstage, yeah, so you can't see my screen actually. Let me show you that. Oh, can I share my entire screen? Yeah, here we go. So here's Backstage. And if you haven't seen Backstage, Backstage has here the service catalog, the overview, and we can then actually scaffold something. So what we are going to do as a developer, I'm a developer now as a user persona, and I'm going to scaffold a new service. So all I do is I hit create, and I go ahead and I say, give me a pod info template, and I give it a name. I always use German beer brands, Perleberger Pilsner, great beer, by the way. I review, I create, I look at the logs, and I can see that all Backstage is doing is that it's taking that request, it's reaching out to the GitHub template API, forwarding a couple of parameters, and then it is cloning a repository and makes sure that GitHub action is running. So let's look at our repository here, and I'll just move this into this browser because this is where I'm authenticated. And we can see we have a repository called Perleberger Pilsner. We have our normal workload source code, and we have a score file. And if we look back at our reference architecture, we've started here in our portal, and I've scaffolded an application source code repository. An application source code repository contains the abstract description and the workload source code, which is exactly what we're seeing right here. Now, the CI pipeline runs. So if I'm following through, the CI pipeline runs, it pushes this to an image registry, in this case, ECR. It then hands over to an orchestration. The orchestration makes sure that the resource plane is in the right stage, and monitoring and logging is configured, and all of this. So let's go here, initial commit, build and notify the orchestration. We have the push to the ECR. We have score, all of those different components. If we have a look at score, here, that's the abstract description. We can see that it says, hey, I am a service called Perleberger Pilsner. I need a DNS. I need a route. Can you give me that? And then I'm ready to go. So the experience we want for the developer is to now be already able to configure. We want to take this URL, run git clone, everything should be set up. I wouldn't even need to look, I should just be able to trust. But we want to make extra sure, so we'll go into Backstage and we'll look into the catalog, and we'll see that we have now a development environment for the Perleberger Pilsner service. We're now in the service catalog, and we have a workload running. We have a DNS. If we click on this, we can look at the DNS. We have a little whale here that is saying hello, everybody's happy. And we can see that there is DNS and all of that good stuff. So far, so good. Namespace is there, logging is there, all of these things, certificate, and we can go in. Pipeline is wired. We can go in, we can clone right away. It was a super nice experience, but it's pretty trivial experience. So what I just showed you is something you can just do with GitHub Actions and Terraform. Should be totally sufficient to pull that off. You don't need a graph-based system for that. The power of the graph-based system, that's actually coming in after day 0, if you want to put it like this. So let's say we're developers again, and we've been developing that service for a while, and now we want to add a new dependent service. We want to add a Redis. So all we have to do is we go into our code, obviously not into our version control system, but in our IDE, and we say, give me cache of type Redis. And if we're ready, we commit the change. And then, unfortunately, the development environment is blocked because my colleagues are currently testing something. So I'll create a new branch, propose the change, and we'll create a pull request. It's now actually going to check this. Actions is going to kick in again. GitHub Actions is now going to receive the information that there was a change to the score file. It's now saying, hey, we still need DNS, we still need route, that's all fine. But in addition to this, we also need cache. And attention, this is a new branch. So what we've done is we've configured this in a way that at PR, we want the orchestrator to spin up an entirely new environment that looks like development, that feels like development, but that isn't development. It should be what the resources are one-on-one configured exactly the same way to make sure we have the same behavior, but it is an entire copy of development, however we want to do this. And the beauty of this approach is that we're now able to say, hey, I want Redis to run in cluster. I want you to create a new namespace, not a new cluster. I want to use a shared database, however I want to do this. So again, let's look at the action here. We are actually here pushing the update of Score. We can see that this is now running through. It's being pushed to the orchestration. Score is translated into a JSON format to make sure that the orchestrator API can actually consume this. Also an important bit here, that the everything is API based. I should be able to send that request. I need a new Redis in whatever form I want, in a CLI, through Backstage directly, through the code as I just did this, through an SMS service, really whatever I am up to. Then we are actually posting this to ECR, and then our job is done and we can clean up. Right, so now I'm looking back at Backstage, and surprise, surprise, I have 2 environments. I have the development environment, I have the PR environment, and the PR environment, called Perleberger Pilsner, should now include cache. And again, good news, we now have a cache, and that cache was configured in cluster, and we have the new service up and running now. You can see that those are different randomly generated strings. Okay, perfect. So now I can work in PR1. I have end-to-end symmetric infrastructure here, absolutely the same. And now let's look at back at the CI. We can also see that the CI pipeline is also surfacing this information. When you saw that what I said last, that we want to make sure that we have as little interface breaks as possible. So you can see that as a developer, I would have not needed to go into Backstage if I don't want that, because the CI is actually surfacing all of that information already. We can see that the orchestrator has actually forwarded the DNS name here, the diff, the resource graph, all of those different things. We can merge the pull request now and say, hey, we're ready. And then what this will do is that it will automatically, again, reach out to the orchestrator and say, like, hey, orchestrator, good news, we don't need the PR environment anymore. We can fold the cache back into the running development environment, and we can clear the PR1 environment because we want to save money. So in a couple of seconds, PR1 is going to go away, which has just happened, and development is going to start updating and then making sure that cache is in the development environment. Last thing that I want to show you is actually the resource graph. This is not added. Yeah, so now you can see that this is in progress. Last thing I want to show you is the resource graph. This is not yet in the plugin for Backstage, but coming soon. I'm going to show you that here. if you look at a larger organization, you can visualize the resource graph, which I think is super cool. And this is how this looks. Where are we? Deployment, this deployment, and we look at the resource graph. So here we have the resource graph with actual stuff, and we can go through this and we can see the dependency between all of those different components. We can see that here, this is a RabbitMQ that is using the global config definition for called dev RabbitMQ. It took us 8.1 seconds to provision this. We can add more metadata, how much this costs us. We can look at what's running in what namespace, and we can really browse through the dependencies of all of those things. Again, all of those things are specific endpoints. That is the power of the graph. Good. This was a lot of information, but I hope helpful. I'll stop our little demo here for today and see whether there are any questions. No questions? That's a lot of information, huh? All right. If there are no questions, then I think we are done for today. All right. So keep in mind that, obviously you can test the Backstage plugin. You can test the Backstage. You can test those reference architectures. There are reference architectures for many different providers already. With Backstage, you have, for instance, the one for Red Hat OpenShift. You have the one for Amazon. You have the one for Google that you can really test out yourself, play with it. We are running a lot of different interesting. Have you used Backstage in .NET shops? Yeah. So that's absolutely possible. We are seeing a large uptake in the also in the Azure and the Microsoft ecosystem in general. That is absolutely possible, William. Yeah. The reference architecture is something to watch out for. We also have the different providers and clouds demoing and over like this a lot. I'll be with Amazon in Oslo. I was just in Vegas with Google. Google has been publishing reference architectures for these different things, and that is absolutely possible. In VMware environments, that is an interesting question. In VMware environments, that is possible. Unfortunately, so far, the backends, there are not many backends that are really optimized on the VMware ecosystem. We are now just folding in the capability of orchestrating VMs. And that is definitely something that's coming out. But for now, the VMware environments were historically more on the view and assist. Then we have Philip. Do you have a blog or prior webinar that shows more of an evolutionary approach to building out these capabilities? For example, GitHub Enterprise Cloud, then Terraform, then Backstage, then Humanitec. Or does the entire blueprint need to be provisioned at once? This is a good question. How do you actually approach this? How do you approach this step by step? There is a project that is attempting to do this, CNOE, I think. I have not. The problem with these things is that it is non-trivial to get that in place in a way that is step by step. Like if I'm talking about adoption, I'm always thinking about, or I'm always recommending to build these reference architectures in one shot, but only test them with one or two applications. It's that idea of a minimum viable platform. But my observation is, if you ask a user whether they want an iPhone, nobody will be able to comment because they don't know how an iPhone looks. So I'm a fan of building something for them that is pretty neat and significantly better than what they're using right now. And then once you have that, you only optimize this for 1 or 2 applications, and you prove the value in a very, very small, narrow part of your estate. And only if that works, you go more mainstream. And then we have Daniel asking about, what about serverless compute such as Lambda and Azure functions? Again, unfortunately, for all those graph-based providers, that is not something that's currently available, at least not that I know. If you know something, do tell me. But I believe we will see this within the next 12 months. So, yeah. Fantastic. If there are no further questions, then we are going to end this here today. Thank you very much for your interest. Good luck with your platform engineering initiatives. We are hosting a lot more of these events every week, really. There will be, Platform Con is not that far out, and there will be a lot more examples, a lot more hands-on stuff. I'm at a lot of different events. I am again in Oslo. We'll be at KubeCon. I am at IDPCon in New York in October. I'll be at Ignite probably with Microsoft. So yeah, lots of events where we can catch up in person. Very much looking forward to this. Thank you so much for joining today, and have a fantastic evening. Bye. Ach, schön, das lief hier alles weiter.